Very good morning, my dear students. Welcome you all to third semester diploma course. Myself, Subramani BY, working as a lecturer at Government Polytechnic, Joida. This semester, I will be handling Digital Electronics 2 subject 5. And this subject is continuation of Digital Electronics 1, which you have learnt in your second semester. And it acts as basics during this semester course. So it is better to refresh once before we start this session. If you could recollect, you have learnt about number systems, Boolean algebra, K-maps, and combinational circuits. This semester, we will start with combinational circuits. So, what is combinational circuit? If you can remember, you have learnt about different logic gates in your second semester. AND gate, OR gate, NAND gate, NOR gate, XOR gate, and XNOR gate. If you combine any of these gates to perform a particular function, then it can be called as a combinational circuit. So combinational circuit is the one in which we combine different gates or interconnect them to build a logic circuit. This logic circuit can be called as a combinational circuit. Example, adders, subtractors, multiplexer, and demultiplexers, encoders, decoders, etc. So the logic circuit obtained by interconnecting different logic gates is called as a combinational circuit. Now let us see what are the characteristics of this combinational circuit. Here in this, you can see the block diagram of a combinational circuit which has n inputs and m outputs. So that is one of the characteristic of a combinational circuit. A combinational circuit can have n input lines and m output lines. Means to say it can have any number of input lines and any number of output lines. If you look at the output, there are many outputs, namely A dash, B dash, C dash up to M. And similarly, if you look at the input, you have many inputs like A, B, C, etc. The output of a combinational circuit depends only on the present value of the input. So that is the most important characteristic of any combinational circuit. That's what the first point says. The output of combinational circuit at any instant of time depends only on the present values of the input. So the outputs A dash, B dash, C dash, etc. depends only on the present values of the inputs A, B, C, etc. So because the present value of the output depends only on the previous present values of the input, the circuit will not have any memory because the output is depending only upon the present values of the input. So it need not to store the previous values or past values of the input. So the combinational circuits will not have any kind of memory. So these are the three characteristics of your combinational circuit. So the first one is the output of combinational circuit at any instant of time depend only on the present values of the input, not on the previous or past values of the input. So the combinational circuit does not have any memory. So that is the second characteristic. So the third one is a combinational circuit has n input lines and m output lines. That means to say the combinational circuit can have n number of inputs and m outputs. That is any number of inputs it can have and any number of outputs it can have. So it is clear combinational circuit is the one in which we combine different gates or we interconnect different gates to form a logic circuit. The logic circuit obtained by interconnecting different logic gates can be called as a combinational circuit. Example, adders, subtractors, multiplexer, demultiplexers, encoders, decoder, etc. You have learnt about adders, subtractors in the last semester. This semester we'll be learning about mux, multiplexers, demultiplexer, encoders, decoders in the coming sessions. So characteristics, as I told you, it has three characteristics. Output at any instant depends only on the present values of the inputs. The combinational circuit do not have any memory. A combinational circuit has n input lines and m output lines. Now let us take an example of a combinational circuit. As you can see here, three gates are interconnected to build the logic circuit. Two AND gates are there and one OR gate is there. As you can see in the truth table, the output Y depends only on the present values of the input, and the circuit has two inputs and one output. Here you can see here, so the AND gate, the logic diagram what you are seeing here, so two inputs are there, A, B, two AND gates are there and one OR gate is there. So A, B are the inputs and Y is the output. So this AND gate will perform in the AND operation between A and B. The second AND gate is performing the AND operation between A and B dash. So the output of these two AND gates is given as input to the OR gate, and the OR gate will be calculating the final output, that is Y is equal to AB plus AB bar. Now you can see at the truth table, so A, B are the inputs. Two inputs are there, so we will get four combinations 0, 0, 0, 1, 1, 0, 1. AB, if you look at the first AND gate output, the AND gate gives the output 1 when all the inputs are equal to 1. So here for an AND gate, A and B are the input, so the output is 1 in this case. Remaining all the cases, the output is 0. So now to look at the second AND gate output A B bar. The AND operation is performed between the inputs A and B bar. So A is here, B bar is here, 0 1, the output is 0, 0 1, output is 0 0, the output is 0, 1 1, the output is 1. So then 1 0, the output is 0. This is the second AND gate output. Now these two are given as input to the OR gate. So this is the final output. Y is equal to AB plus AB bar. As you can see, 0 plus 0, it is 0, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1. Because the OR gates generates the output as 1 if any one of its input is at 1. By looking at this combinational circuit example, so you can conclude that any combinational circuit can be represented in any one of the following method. That is by using truth table or by using the logic equation or Boolean equation or by using the truth table. So any combinational circuit can be represented by using any of these ways or all the three ways. Now let us move to the next topic, multiplexer. In this session, we will learn about what are mux, their classification and work. Multiplexer is a combinational circuit with n inputs and one output, and m select inputs, which are also known as control inputs. So multiplexer is a combinational circuit with n inputs, one output, and m select lines, where the number of input lines n will be always equal to 2 power m. So the select inputs are also called as control inputs because they will be controlling the inputs. So multiplexers are also called as data selectors or simply mux. Mux are called as data selector since they select line any one of the input line and connects it to the output line. Which input is selected depends on the values of the select input. They actually control the selection of the input, so they are called as control input. A multiplexer, what actually it does is, if you can see at the block diagram, this is the block diagram of mux, which has n inputs and m select lines and only one output will be. So it is called as n is to 1 multiplexer. There is a relation between the number of input lines and the select input. If there are m select lines, then the number of input lines will be equal to 2 power n. So we will have 2 power n is to 1 mux. So if you are having m select line, we will have 2 power n input, 2 power m input lines. So in general, mux can be represented as n is to 1 multiplexer. Always you have to remember that mux will always have only one output, that is single output. In addition to this input lines and the select line and the output, you are able to see one more input named as E. This is called as the enable signal. So what is the function of this enable? The function of this enable signal is to just enable or disable the mux. There are two types of enabling, active high enabling and active low enabling. So if this mux is activated when the enable signal is 0, if the mux is activated when the enable signal is 0, then it is called as active low enabling. If the mux is activated or if the mux is working when enable is equal to 1, then it is called as active high enabling. Is it clear? I hope it is clear. So mux is a combinational circuit with n input lines, 1 output lines and m select lines. So the relation between select lines and the input lines is given as n is equal to 2 power m, where n is the number of input lines and m is number of select lines and one output will be there. Because here there are many inputs and one output is there, the mux is also called as many to one circuit. Or simply it is selecting any one of the input and sending it to the output. It is also called as data selector. So mux is a combinational circuit or many to one circuit or simply data selector. So in simple words, if I want to say, so the mux basic function of mux is to select any one of the input line and send it to the output depending upon the inputs on the select lines or the control lines. So it is very simple. It will select any one of the input and send it to the output. Which input is selected depends the values on the select. Now let us see the types of mux. As I told you, there is a relation between the number of select lines and the input. If there are m select lines, then there will be 2 power m input. Now, if the number of select lines is equal to 1, then we will get 2 is to 1 mux or 2 to 1 mux because n is equal to 2 power m. Here m is equal to 1. That is one select line is there. So 2 power m, that is 1, becomes equal to 2. So therefore, we will get 2 to 1 mux. Now, if you take the number of select lines, that is m is equal to 2. 2 select lines are there. So then 2 power n, 2 power 2 becomes 4. Therefore, we get 4 to 1 mux or 4 is to 1 mux. Similarly, if we take 3 select lines, that is m is equal to 3, 2 power 3 is 8. So we get 8 is to 1 mux. Now, if we take 4 select lines, we'll get 16 to 1 mux. That is 2 power 4 is 16. So we'll get 16 to 1 mux. So you can keep on increasing the select lines and we can get different types of mux. Now let us take up the 2 is to 1 multiplexer. It is a simple multiplexer with 2 inputs, one select line and one output. The number of input lines can be anything, but always the number of output line will be equal to 1 for any mux. So here it is the block diagram of the mux 2 is to 1 mux. As you can see here, two inputs are there, D1 and D0. D stands for data. Sometimes instead of D, we use I also, or we use A, B, C also. Here two inputs are there, D1, D0. One select line is there denoted by S, and one output is there denoted by Y. And in addition to this, we have one enable signal. As I told you before, there are two kinds of enabling, active low enabling and active high enabling. The function of this enable signal is just to enable or disable this mux. Depending upon what kind of enable we are using, this mux will be in the working condition or in the non-working condition. For all the mux, I have taken active high enabling. That is, the mux will work when enable signal is high. In other case, that is when enable is 0, the mux will not be working. That you can see in this truth table. So the inputs enable, select line yes, and the output Y. Now look at the first case. Here, when the enable signal is 0, irrespective of your select input, the output is at 0 because it is active I enabled mux. When enable is 0, this mux will not work. So that's why when enable is 0, whatever is the select line, so the output will be at 0. Now let us make the enable signal as 1. When enable is 1, this mux will be activated. So but the output depends upon the select line. There is a one select line, so it can have two values, that is 0 and 1. When select line is 0, let us assume D0 is connected to the output. D0 is selected and it is sent to the output. When select is 1, D1 is selected and it is sent to the output. The same thing is written in the truth table. When enable is 1, it will check for select signal. Depending upon the select signal value, it will select any one of the input, either D0 or D1, and it connects to the output or it sends to the output. So when enable is 0, irrespective of your select input, the output is at 0. When enable is 1, it will check for the select input. If enable is 0, if a select line is 0, the D0 input is selected and it is sent to the output. If select input is 1, then D1 is selected and it is sent to the output. As I told you, any combinational circuit can be represented in three ways. So that is truth table, logic diagram, and the Boolean equation. Here we have represented this 2 is to 1 mux in truth table. So we can represent in logic equation form also, and we can represent it also in the form of a logic diagram. That we will see in the next slide. So to write the Boolean equation, we need to have the truth table. The output Y we are getting in these two cases. That is when enable is 1 and select line. Depending upon select line, we are getting two outputs, D0 and D1. So D0 we are getting when select is 0. Therefore, the output will, min term will be S bar D0. And in this case, select is 1 and the output is D1. The min term corresponding to this output will be S D1, which you can see in the next case. So here we have written, so the output equation as